When it comes to working with databases, I believe there's two types of software developer. Those that like to use ORMs, and those who prefer to write SQL. As for myself, I'm definitely that kind of developer that likes to get his hands dirty, writing raw queries. But I also make sure to be safe, which means I use protection. That protection typically comes in the form of abstraction, wrapping the raw queries in a type-safe construct, using the repository design pattern. By doing so, it provides a number of benefits. The first, and most obvious, is that you get to write your own SQL, meaning you have full control over the queries that are being performed against your database. Additionally, by abstracting my SQL queries into a central repository type, I'm able to constrain my database operations into a single location, which prevents me from needing to sprinkle SQL queries all across my code. Instead, because these queries are wrapped inside of their own functions, the operation itself becomes type-safe due to the implementation of concrete types for both the query inputs and outputs. This not only has the benefit of decoupling my database implementation with the application logic, but makes it really easy to reuse these queries across my code. All of this makes the repository design pattern my preferred approach for working with databases in my application code. But as with all design patterns, there is a trade-off. In this case, that trade-off is time, as you typically have to write this repository implementation by hand. This can be somewhat tedious, as most of the code that's written ends up just being boilerplate. For those developers who aren't AI adverse, then this may not be too much of an issue. But for myself, I'd much rather just write these SQL queries by hand, and have the actual repository boilerplate be generated. Fortunately, it seems I'm not the only one who thinks this way, as some rather clever individuals have created what I think is the perfect solution: SQLc, which was actually recommended to me by a couple of members of my Discord channel. And after having used it for about a month now, it's dramatically reduced the amount of time it takes for me to write code that works with SQL queries. So much so that I don't think I'll ever go back to a time where I didn't use it. The way SQLc works is actually rather intuitive. It starts with what is arguably the most important part of working with a database: the queries themselves. When it comes to SQLc, you define your SQL queries inside of a .sql file, using annotations to define the query's name and the query type. Then, by using the SQLc generate command, you're able to generate code in your chosen language that is both type-safe and matches the repository design pattern. If the term generate code gives you some pause, then I get it. I've been known to have my own strong reaction whenever somebody mentions CodeGen to me, so when I first heard how SQLc worked, I was initially skeptical. However, after having now used it a few times, I think the code generation has been implemented in one of the best ways I've ever seen. Not only does the generated code look pretty similar to how I would write it, but you're also able to customize it in whichever way you need. This includes which language you generate your code into, as SQLc not only supports 4 languages natively, which are TypeScript, Kotlin, Python, and Go, but it also supports a number of other languages using its plugins feature, which allows you to add any language support that you may want. Not only this, but SQLc also supports 3 different SQL engines: Postgres, MySQL, and SQLite. Additionally, it manages to achieve all this without adding any additional dependencies, instead making use of popular packages for each respective language, whilst also allowing you to configure which types and packages are used by the generated code. All of this makes SQLc incredibly easy to use, as it can be easily customized to fit your own requirements. Before we look into SQLc, however, let me first pay some bills by asking you 2 questions. Question number 1. Are you interested in learning back-end web development using either Python or Go? And question number 2, do you happen to like role-playing games? Well, if you answered yes to both, then you may be interested in the sponsor of today's video, boot.dev. Boot.dev is an online platform where you can learn back-end web development from start to finish, using both Python and Go. The team at boot.dev believe that the smartest way to learn to code is to make sure that you're never bored, which is why they have implemented aspects from role-playing games into the platform. This means that by learning, you'll also earn XP, levels, achievements, and complete quests in order to reach the top spot of the leaderboard. The platform is designed to get you writing a ton of code, as getting your hands on the keyboard and shipping is one of the best ways to really learn. Because learning to code can be kind of spooky, Boot.dev do as much as they can to try to make it as risk-free as possible. They achieve this by providing a free demo of every course and its interactive features, as well as offering a 30-day, no questions asked refund policy, enabling you to test if the platform is right for you. Therefore, in order to learn all of the skills you need to become a back-end web developer working in either Python or Go, then click the link in the description down below and use my coupon code DREAMSOFCODE to get 25% off your first payment for Boot.dev. That's 25% off your first month or your first year, depending on which subscription that you choose. A big thank you to Boot.dev for sponsoring this video. To show SQLc in action, let's begin with a simple example of how it works. Here I've created a simple application which performs data operations to represent an online role-playing game. If I go ahead and run this code, you can see it pulls all of the game's players out of the database and prints them to the console in a tabular format. The code for this project is pretty simple. All it does is connect to a Postgres database using the fantastic PGX package, which is my favorite Postgres driver to use when it comes to Go. After connecting to the database, the code then calls the getPlayers function, passing in the database connection. This function acts as a basic abstraction of the database operation, wrapping the raw SQL query and returning a type-safe result. Basically, this function acts as a simple implementation of the repository design pattern that I mentioned before. Despite this function having a relatively simple implementation, there's still a lot of boilerplate that goes into supporting the core functionality, which basically boils down to the SQL query on line 38 and 39, and encoding the rows into our concrete Go type, the player struct. Therefore, let's remove this boilerplate from our code by using SQLc instead. To begin, we need to create a new file called sqlc.yaml. This file is used to configure SQLc in order for it to work with both our project, our database schema, and our database queries. Inside of this file, the first thing we need to define is the SQLc schema version, which at the time of recording is version 2. Afterwards, we then define the SQL block and SQL engine that we're going to use, which in this case is Postgres. With our SQL engine defined, the next thing we need to do is to define our database schema. This can be achieved using a couple of different approaches. If you're using a database migration tool, such as the fantastic Golang migrate package, then you can easily set the value of this field to be the directory that contains your database migrations. This is my personal preferred approach, as it allows you to keep both your SQLc schema and database in sync, which you can easily ensure by using CI/CD. If you don't happen to be using the migrate package for migrations, then SQLc does support other database migration tools as well. The documentation contains a list of which tools are supported. If you're not using database migrations, which you really should be, then you can either write down your database schema in SQL, or better yet, dump it from your database using the following pgdump command. Whichever approach you take, once you've defined where your database schema lives, the next thing to do is to define where SQLc can find our queries by setting the queries field. For the value of this field, this again can either point to a single file or a directory which contains multiple SQL files inside. In my case, I'm going to set this to a single file called query.sql, which I'm now going to go and create. This file is where all of the SQL queries for my project are going to be defined, starting with adding in the select query I'm already using inside of my application code. However, instead of this being the exact same query, I'm going to make a small but welcome change. Rather than explicitly defining each of the columns we want to select, which is typically needed when working with SQL in Go, instead, I'm going to replace this with the select star syntax in order to select all of the columns in the table. With that, our query is now defined. The next thing we need to do is to give it a name. This is done through the use of a SQL comment on the line above the query. In this case, I'm using the following syntax to give this query the name of findAllPlayers. In SQLc, this is actually known as the annotation, and is required for each query we define inside of our queries file. In addition to the query name, this annotation also needs to define the command that the query will use. SQLc provides a number of different commands you can choose from, each of which are similar to commands found when using either the PGX or database/SQL packages when it comes to Go. The three ones that I use most are the one command, which returns a single row, the many command, which is used for returning a slice of rows, and the exec command, which is used for queries that don't return any rows. For a full list of the available commands, I recommend checking out the SQLc documentation. In the case of this current query, because it can return multiple rows, then we want to use the many command, which is done using the following syntax. With both our query and annotation defined, let's head back on over to our SQLc.yaml file in order to configure the code generation. In my case, I want SQLc to generate Go code, which I can achieve by adding in the following 2 lines. Then inside of the Go block, the next thing to do is define the package name of the generated code. In my case, I'm setting this package name to repository. Next, we then need to define where in our file system we want this generated code to be output to, using the out key. In my case, I'm setting this to be the internal/repository directory of my project. With that, the first iteration of our SQLc config is good to go. Let's go ahead and use it to generate some code. To do so, we first need to install the SQLc binary onto our system. SQLc is available for both macOS and Linux in their respective package managers. If you're using Arch, you can install it using Pacman, by the way. Or if you're using macOS, then it's also available on Homebrew, by the way. However, if you like to live declaratively, just like me, by the way, then fortunately it's available on the Nix package manager as well. Whichever approach you take, once the binary is installed, go ahead and run it using the SQLc generate command. This will generate a number of source files in the directory we defined. Let's take a moment to quickly go through this generated code. First of all, we have the db.go file, which accepts a database connection and returns a query type. This is the constructor that we'll use in order to access our database queries. Next up, we have the models.go file, which contains generated data types used to represent our data model, based on the database schema and the queries themselves. Lastly, we have the query.sql.go file, which contains the actual implementation of our database queries, converting them into our Go types. If we quickly take a look at this implementation, you can see it's actually very similar to how I had implemented this by hand, which is really reassuring to see. Lastly, you'll notice that the name of this file also contains the name of the associated query file. We'll take a look at why that is later on. For the meantime, however, let's integrate this code into our application by first heading on over to the main.go file and deleting a bunch of code. Very nice. With the boilerplate deleted, let's go ahead and use the code that SQLc generated. To do so, let's first call the constructor function of the repository package, passing in our pgx connection. Next, let's go ahead and retrieve all of the players from our table by using the findAllPlayers method. This method will use the query that we defined inside of the query.sql. For the sake of brevity, I'm choosing to not add any error handling into these examples, just as an FYI. If we take a look at this method's signature, we can see it returns back a slice of the player type, rather than returning any unsafe SQL rows. We can use the following go.doc command to view what this player type looks like, which is actually similar to the player type I defined before. Again, that's rather reassuring. With our slice of players in hand, let's go ahead and print them to the console using the print players command I've defined earlier. If I go ahead and run this code, you can see that it returns the same result as it did before, all whilst having less lines of written code, yet still performing our own defined SQL query to retrieve the data. Not only that, but because everything is now set up, it's also incredibly trivial to now make changes to our SQL query. For example, if I want to order these players by level, I can do so by making the following change to the query inside of my queries file. Then, if I run the SQLc generate command to regenerate this code, followed by rerunning the application using the go run command, the game's players are now printed out ordered by their level. Pretty great. But to be fair, this would have also been simple to do using the repository pattern I had before. Therefore, let's go ahead and turn this up a notch by adding in a brand new query. To go along with this query, I've created a second table in the database migrations called item. This table is used for storing any available items that can be found in the game. Let's go ahead and create a query to insert a row into this table. To do so, let's begin by defining the query's annotation, by first giving it the name of insert item. As for the queries command, I'm going to set this to be exec, which means this query won't return any rows. Next, let's go ahead and define our actual query, which should insert a row into the item table with the following 3 columns. For the ID value itself, as I'm using a UUID, I'm therefore going to generate it using the UUID generate v4 function, which is found inside of Postgres when using the UUID OSSB extension. Make sure to enable this using the following SQL if you're following along at home. Then for the other 2 values, I'm going to define that these will be passed in as parameters using the following syntax. With that, our insert item query should be good to go. Let's go ahead and use the SQLc command to generate the code before we go about integrating it. If we quickly check the query's type from the repository object, you can see that we now have a new method called insertItem. This method takes a context.context as its first parameter, followed by the insertItemParams type of the repository package, which is a type that's been generated by SQLc to encapsulate the query's parameters. If we quickly check out this type using Godoc, we can see that it contains 2 properties, the first of which is a string representing the name parameter, and the second is an int32 that represents the item's value. Both of these correlate to the 2 input parameters defined by the insert query. SQLc has parsed this query and generated a type based on these input parameters. Very cool. Let's go ahead and quickly finish this implementation. Here, I'm going to create a new item with the name of Ruby and set the value to 300. Now, if I go ahead and run this code, followed by checking the database, we can see we've now created a row inside of the item table with our given values. However, there is a modification I want to make to this query. When it comes to inserting rows inside of a database table, sometimes it's beneficial to return that newly created row as a result. By doing so, you're then able to access any generated fields, which in this case would be the item's ID. Let's go ahead and make that change inside of our insert item query. To do so, all we need to do is add the returning star command to the end of our insert query. This will cause all of the columns of the newly inserted row to be returned. Because this query now returns a result, then we need to change the command that is going to be used inside of the annotation. Let's change this from exec to 1. With our changes now made, we can go ahead and generate this code using the SQLc generate command. Now, if we take a look at the insert item method that we used before, we can see it has an additional return value of repository.itemType, in addition to the error type it had before. This repository.item type has also been generated by SQLc. If I quickly make some modifications to the insert parameters, this time creating a new item called diamond with a much higher value, we're now able to capture the query return value and print out the new item's ID. However, when I go and run this code, you'll see that the item's ID value is printed out a little strange. This is because, by default, SQLc will map the UUID in the database to the struct of pgtype.uuid, which, in my opinion, doesn't have the greatest interface. Instead, it would be much more preferable if we could use the fantastic UUID package provided by Google, which is honestly the de facto standard when it comes to working with UUIDs. Fortunately, SQLc provides a way to achieve this, using its fantastic overrides feature. This feature allows you to override the types that SQLc uses when mapping from the database schema. Let's go ahead and set this up. First, by using the following goget command to add the package to our project. Then we can define the overrides we want inside of our SQLc configuration by adding a list of entries to the overrides key. Let's go ahead and add an entry to override the DB type of UUID. This is done by adding in the following line, specifying the DB type we're overriding. Next, we need to define which type we want to overwrite it with. This is done by adding in the following lines. First, defining the package where the type lives, using the import key. In my case, I'm setting this to the Google UUID package. Next, we then need to define the name of the type we want to overwrite with, in this case, UUID. Now let's go and see if our item's ID prints out in a UUID format. First of all, I'm going to delete the existing diamond item from the database. Then use the SQLc command to generate the new code before running the application using go-run, which now prints the new item's UUID in a much more readable format. If we go ahead and take a look at the item type using Godoc, we can see it's now using the overridden UUID type, making the item struct a lot more friendly to work with. Another great feature of overrides is that they also apply to any generated query parameters. For example, if we add a new query to find an item by its ID, and generate this code, we can see that the generated function expects a UUID type. If we didn't have this override in place, it would instead expect the PG type UUID, which is a much harder type to construct. When it comes to overrides in SQLc, these can be used for more than just UUIDs. For example, I also like to use them when it comes to the timestamp types, such as timestamp TZ. In this case, I like to override these to use the time type of the time package found in the standard library. This is done by adding in the following lines into the SQLc YAML. By setting this, it will replace the PG type timeTZ type in the player struct with our desired time.time type instead, which is much more usable in my opinion. In addition to using overrides to configure the generated types, SQLc allows for a number of other configurations you can make to the generated code. One of these that I use frequently is the emit JSON tags option. By enabling this option, SQLc will then add JSON struct tags to the generated types, which means you can then encode this generated type into JSON with correctly formatted fields in snake case, rather than the camel case that Go will default to. Additionally, another great customization is the ability to embed structs into your data types. To show this in action, here I have another table called inventory, which stores a list of player item mappings. To pull out these mappings, I can use the following query, which will pull out every player and item column in the table using a left join. In the real world, you probably wouldn't use a query like this, but this is YouTube, so let's just roll with it. Anyway, if I go ahead and generate the code for this query, you can see it comes out a little strange. This is because both the item and player types share some commonly named fields. SQLc deconflicts these by using a kind of odd approach, by specifying a different number value after each conflicting name. Not only this, but when it comes to using the results of this query, because it comes back in a flattened struct, you end up needing to write boilerplate in order to convert it into the concrete type, which is exactly what we're trying to avoid by using SQLc in the first place. Fortunately, SQLc solves this through the use of its embedded structs feature, which configures SQLc to reuse existing generated types inside of this query's result. This is achieved by using the SQLc embed macro inside of the SQL query, using the following syntax. Here, we're using it to embed the already existing types that have been generated for both the player and item table. Now, when I generate this code, you can see it embeds the existing types of player and item, rather than generating a flattened struct, which in my opinion makes it a lot easier to work with the results of this query. As you can see, SQLc comes with a lot of features, but in order for it to work in a production setting, then there's a couple of others that we're going to need. The first of these is prepared statements. Fortunately, when it comes to SQLc, this is again rather simple. If you're using Go with version 5 of the PGX driver, then prepared statements are handled automatically, without the need for any additional configuration. When it comes to other database drivers, however, then you'll need to set the emit prepared queries option to true inside of your SQLc config. As well as handling prepared statements automatically, SQLc also makes it really easy to use database transactions as well. SQLc handles these without the need to do any additional configuration, all through the use of interfaces. Let's see how this works by implementing the following function for when a player sells an item. The goal of this function is to remove the item from the player's inventory before adding the item's value to the player's gold, which is a column I've just added using the following SQL migration. In order for the sell item workflow to take place, I've defined the following 3 queries. The first query is used to pull out the item from the player's inventory, provided that it exists. Whilst this query does work, I could have used the existing find item by ID query instead, as it effectively does the same thing. As they say, however, hindsight is 2020. The second query we've defined is to delete an item from a player's inventory, given a player and item ID. Rather than the command for this query being exec, I've actually defined this as exec rows, in order for the query to return the number of rows that were affected. This allows us to easily check whether or not the item existed in the player's inventory. The third and final query is used to modify the player's gold value by a certain amount. For this query, we're passing in 2 parameters, the amount we want the gold to increase by, and the ID of the player whose record should be affected. If this query fails for any reason, then we'll want to roll back the associated transaction, reverting the deletion of the player's item from their inventory. If we take a look at this query in more detail, you can see that I'm using 2 additional SQLc macros on the following 2 lines. This is the SQLc.arg macro, which allows you to name a parameter inside of your SQL query, which will be reflected in the generated code. In this case, I'm setting the names to amount and player ID, as well as setting their types to int and bigint respectively. If I wasn't explicitly defining the names of these arguments, instead using the same syntax as the previous queries, then the names in the generated code for these two input parameters would instead be set to gold and ID. Whilst either approach is acceptable, personally I think this is still a really cool feature. And in my opinion, setting these names for the input parameters makes the code a little more understandable. Either way, with our queries now defined, let's take a look at how we can use them inside of a transaction. To do so is similar to how we were constructing the repository before, using the new function. However, rather than passing in the database connection, instead we create a new transaction from it using the begin method. Then we can pass in this transaction into the repository constructor, as it conforms to the same interface that it's expecting. Now, any queries that we perform using this instance of the repository type will be performed on the database transaction we passed in. Let's go ahead and implement the rest of this function. To begin, let's start by adding in a deferred rollback for this transaction, in case something goes wrong. Next, I'm going to quickly speed run through the actual implementation. But one thing to take note of is I return early if ever we encounter an error, which will cause the transaction to roll back. Then after each of these three queries have been performed, I'm calling the commit method of the transaction. If you want to study this function in more detail, you can find a link to the code in the description down below. Now, if we head back to our main function, we can then call this new sellitem function, passing in the database connection, the player ID, and the item we wish to sell. Now, if I go ahead and run this code, we receive back the console output, letting us know that the operation completed. If I quickly check the database, we can see that the inventory item no longer exists for the player, and the gold amount in the player's row has increased by the item's value. The last thing I want to show is how to organize your projects once you start to have a lot of queries. If we take a quick look at our query file, you can see it's starting to get a little messy. Whilst some people are fine to work inside of a single file this way, I personally prefer to organize my code using multiple files instead. Fortunately, SQLc allows us to do this by setting the queries value in the SQLc.yaml to a directory, rather than a single file. In my case, I'm setting this to be the query directory, which has a number of different files inside. Personally, I tend to group my queries together based on their associated type, which means I have a file for my player queries, a file for my item queries, and a file for my inventory queries. If I go ahead and generate this code, all of the queries will still live inside of the same repository package. Instead, however, we now have multiple files inside, one for each respective SQL file found inside of the query directory. That wraps up how I've been using SQLc when it comes to my own projects. Personally, I absolutely love this tool, given how much time it's saved me while still allowing me to write raw SQL queries when it comes to working with databases in my application code. Because of this, SQLc has now become a permanent fixture in my Go development stack. If you're interested in what that full stack looks like, then let me know in the comments down below and I'll do a dedicated video on it. Otherwise, I want to give a big thank you to boot.dev for sponsoring this video. If you're looking to learn back-end web development in either Python or Go, then I really recommend giving the platform a look. If you do, then make sure to use my coupon code DREAMSOFCODE to get 25% off your first payment. Otherwise, a big thank you for watching, and I'll see you on the next one.